Okay, hello everyone, and welcome to the long-awaited data science workshop number 2. Let me put it in presentation mode first. So, I'm gonna do a quick recap because it's been a while. I think more than a month now since Data Science Workshop 1. So I guess a lot of people might have forgotten the data science lifecycle. So this is the basis of how we're going to be explaining these concepts, as well as showing you the practical application of these concepts. So PhazeRo, as we know, we're a data science workshop or shop. We have AI, machine learning projects, as well as software projects that are full stack and so on and so forth. So I'm going to be revisiting the life cycle. So this is the infamous image that I've been using for some time. We'll go into each part separately in the stages. And as the name suggests, it's a life cycle. So that means we don't start at one point and then end and that's it. It's a continuation. Not only that, sometimes in the life cycle, you skip a stage, you go back a stage. So data science in general is not that clean. There's a lot of mess involved. So, but generally, this is the structure. It's a life cycle. So first, going on with the business understanding. So first step is understanding the problem, what we're trying to achieve, what we're trying to do with our data, and what is the value that is going to be extracted from this understanding. So why do we do this? We want to align the data science project with the business goals. Okay, we want to ensure that the results are actionable, so it's something that is actually tangible and is doable, and we want to understand that it is relevant for the business needs. Okay. How is this done? There are, of course, we do interviews with stakeholders, we do brainstorming sessions, we do SWOT analysis, which is a strength, weakness, etc., opportunities, and so on and so on, and threats. We use project management tools such as Confluence and ZenHub, which we will show you now. We'll show you on the Confluence page where we are going to be summarizing this whole project, and it's a continuation. So you will be able to follow up with this project as well, or with this workshop, sorry, and surveys basically. Okay. Next would be the data collection. And I apologize for going really quickly through these because we've gone through these before, but it's just a recap. So what is data collection? Is basically collecting data from various sources, either they be from files, databases, real-time streams, or first-hand data, such as generating your own data. Okay. We do this because we want quality, as well as we do need quantity for the data that's being collected, and it does affect the insight and accuracy of the solution that we're going to be providing. And of course, with this data, it sets the whole foundation for our analysis. Okay. So the ways we do this, the tools that we have, APIs, for example, a lot of the data that is collected can be in CSV format, JSON format. Sometimes you get this data from data lakes, which are all unstructured, and then you organize them, you put them in proper ways, and then that's put in a data warehouse. Another way, of course, is scraping the internet. So that's using web scrapers. Lots of famous tools, for example, request is for sending HTTP request to a server, and then you'll get, so you do a get request basically. Beautiful Soap is a well-known package in Python that is used for parsing HTML and XML documents. And then there's one off the shelf, let's say, a Scrappy package. It does web crawling, it does the navigating, and it does the extracting as well. Next would be the cleaning of the data. So what is cleaning? So cleaning basically, as I said, data is dirty, so you need to handle it by figuring out what is missing, figuring out what is inconsistent, so removing inconsistencies, correcting inconsistencies. Sometimes you have outliers that shouldn't be there, okay? So that could be an error in the data. And all of this is done so that we can improve the quality of the analysis, which is the next stage. Of course, this whole process of cleaning it takes a very long time. It takes the majority of the time, and there is a lot of subjectivity involved. This we also have to take into account. So sometimes one person does a cleaning differently from another. Some person finds some part of the data dirty, while another finds it perfectly acceptable. So there is some subjectivity involved with the cleaning. As I said, this is crucial so that we have good and accurate analysis. And if we don't do it, this would lead to or would be misleading the results, and then also poor decision making, which results in a poor solution. So data is key. And I think everyone is well aware of this saying that garbage in, garbage out, right? So if you have bad data, then you'll get bad results and a bad solution. So what tools are used for cleaning data? We have the pandas, but infamous pandas is always used by data scientists. Excel and Google Sheets is also perfectly legitimate and useful source of cleaning data. Then there is also more well-established platforms just for visualization and cleaning and other things such as Tableau and Trifecta. And I think Tableau is the paid version. You can get a free version, academic version as well. And then AutoClean is another Python package that is used for cleaning the data. Again, cleaning is subjective, so sometimes you want to do this manually. Then we go on to the EDA, data exploration analysis, or exploratory data and analysis is another way of saying it. So this is where you do the brainstorming, figuring out what the data is, how the data relates to each other. Here you use statistical methods and visualization tools, such as matplotlib is another library that's being used. I'll go into those later on. We want to understand patterns, we want to understand relationship, trends, etc. All of this is done through the EDA part. And this stage also involves a lot of creativity and subjectivity. Okay. But also note that in the data exploratory analysis, we do not change the data. So it's just about looking at the data and figuring out some trends and patterns. So we do this so that we can generate hypotheses. We discover insights of the data, and then this would guide us in how we would go about doing our modeling. Okay. Some tools that I will also showcase are data prep. So there's a Python package for analyzing, preparing, and processing data. Caleb is another one that does automatic EDA. And then I'm going to be using also some visualization tools. So after doing all of this exploratory data, now we figure out, okay, I need to create new input. So the features in this case are the input to the model. And this is where feature engineering comes in. So one of the things that is essential in feature engineering is domain knowledge. So you need to have some, at least basic understanding of what the features represent and what they are, and what is important and what is not. So you need domain knowledge. This is where we transform, we create new features, etc. We do this so that we enhance the ability of the model to learn from the data. So again, going back to quality, some features are useless, or some features, let's say, are not in the form that they should be as input to the model. And this so that we can make accurate predictions and classifications, okay, depending on the problem, of course. So some tools, we have Feature Engine. This is a Python package for feature engineering and selection. We have scikit-learn, has a lot of sub packages that does this, and then we have FeatureWise. So I will showcase scikit-learn and FeatureWise and how they work with feature engineering. And then not finally, sorry. Then we have the modeling part. So in the modeling part, this is where we select the model, where we build the model, where we validate it, see that it's actually properly functioning as it should, and then we deploy it. Okay. And in this workshop, I'm not going to be deploying the model because I'm going to be using a tool. I'm going to be using Google Colabs, and I will go into the Google Colabs and how it works later on. So why do we do this? We want to capture the patterns in the data, and this will provide us more insights and, of course, decision making from those insights. Now with modelings, we have a lot of tools. We have the infamous scikit-learn. Scikit-learn is always most likely used, especially for shallow learning packages models. We have PyCaret. This is a Python package that automates the machine learning workflow. FLAML is another one that is used by or is produced by Microsoft. And we also have Auto Scikit-learn or Auto sklearn. This automates the machine learning process as well, based on the scikit-learn library. Then we have AutoCaret. So this one is a package that automatically creates, searches the hyperparameters of a deep learning models. So it chooses like a number of layers, does the hyperparameter tweaks, number of nodes per layer, etc. Then we have eval-ml, and this one does AutoML. And then we have lazy predict. So lazy predict, it creates a lot of models based on the data you provided, either a class, depending on the class, if it's a classification model or it's a regression model, and then trains many models and then compares them as well. So a lot of automation here. And finally, we have the communication and visualization. So here is after doing all of this work, this is where we do our graphs, where we visualize, we create dashboards, we create reports, people create presentations, etc. So definitely you have to be effective in your communication so that the stakeholders would understand what would be the actions needed. And that's it. I'll leave the questions for later, since this was a recap. And now I will go into our Confluence page. So this Confluence page will be shared with everyone. Let me share it now, actually, copy link. I'll add it here. So if you want to follow along, all right. Okay, and this should be available for everyone. Note, anyone outside the PhazeRo might have an issue accessing this, so we'll figure out a way for others to access this, or maybe even export it to somewhere else so that others can use it. So with the Data Science Workshop, DS2, I will showcase a Google Colab. This one will be using the Titanic data set. So I'll click here and open. Okay. Actually, I think I already have it open. Let me see here. Yeah, I do. Okay. So Google Colabs, a very famous tool that is used by data scientists. One of the things is that with Google Colabs, there's two types of cells. Okay, so we have the text. So this is where we put our titles, where we put our explanations, etc. And then we have a thing called the what do you call it? The code cell. Okay, and then the code cell, I'll show you one of those, is where the actual Python code goes. Now, Google Colab works online. Okay, so you don't need to install anything. You just need to have a Google Drive, so that whenever you open up a Google Colab, you can just save the Google Colab to your drive and then run it. So this one is in my drive right now. So if you want to use this one, I highly urge you to go to File and then save a copy in your drive. Okay, you can also save it to GitHub. You can also download it. And if you download it, you can download it as a IPYNB file or a .py file. So IPYNB files, they work with Jupyter notebooks. So you can also have it running locally. Okay. Also, the other nice thing about Google Colabs, it's that batteries are included. So Python has a policy of having batteries included. This is what they usually say. With this one, there is even more batteries included. What this means is there are some packages that are already pre-installed and preloaded into the Google Colabs. So, for example, the famous ones such as NumPy, Pandas, Scikit-learn, you don't have to do any type of install. Some of which, no, you still need to install, and I'll show you those when we come across them. All right, so starting off, Titanic dataset. So I split up the Google Colabs the same way I did about the data science lifecycle. So we have the business understanding. Here in the business understanding, there are no coding cells. It's all text cells. We'll show you those. And I also presented it in a hierarchy. So this is the highest hierarchy. There's just the title, and then we go into each one of them, and then each one of them will have subtitles, etc., etc. So what's the deal with the Titanic data set? So what is the objective? So the primary objective is we want to analyze the Titanic data set to understand factors that influence the survivals of passengers, like which passengers survived and who didn't survive. Okay. So there is, of course, a hypothesis here that there is a socio-economic factor involved. Okay. So from this whole project, we want to analyze and understand which passengers survived and which didn't, and probably even build them. Not probably, we will build a model that will predict or who survived and who didn't, or what type of person survived and what type of person didn't, in terms of demographics, in terms of socioeconomic status, etc. So then part of the business understanding, we want to do what is this, what is the value of all of this? So we want to study the Titanic data set to provide a gateway to learn about the nuances of data analysis and predictive modeling. So since this is a workshop, I need to use a data set. So this is one data set that teaches you all of this. Now, in terms of the insights gained, we want to understand in a modern scenario like risk. We want to know how to do risk management. We want to know if there's how we can respond to emergencies, etc. Now, given the Titanic happened more than 100 years ago, so there are a lot of differences in terms of the model that we need to build. But Titanic dataset is an excellent learning dataset for this particular workshop. Okay, going on to the problem statement. So we are presented with a classification problem. So why did we decide that this is a classification problem? Because we want to know one of two outcomes. Did the person survive or did not? So it's a classification. It's a binary classification. We have two types of labels. Either you survive or you don't. So now we know that it is a classification problem. Now, the challenge is we want to analyze the relationship between various features, okay? And we'll go into depth into all of these features. So the features, examples of such features are the age of the passenger, the gender of the passenger, their class, family size, etc. So this involves exploring patterns in the data, handling missing values, creating new features, and finally building a predictive model. So we want to use these insights to understand all the underlying dynamics of these features, how they interact together. Okay, so this is the business understanding. We're done with that. Now starts the work, right? Now we go into the data collection. So the nice thing here is that this type of data is readily available. And I can even download it directly as a CSV file, and then I can open it up. So let's go on to how we do this. So basically, first things first, I'm going to be importing a package or a library called Pandas. So Pandas has these data frames. They're really nice. They are like tables with columns and rows. And what we're going to do is we can even, there's different types of ways of loading data into these data frames. The easiest one, for example, is reading it from a CSV. So the nice thing here is I don't even have to download the CSV file. I just need to provide a URL to the repo that has this raw data of the Titanic CSV. So I can even show it to you. Let me copy. Let's go here. Okay. So here we have this raw data that is in CSV format. Now, if you go into GitHub and you find any of those data sets, remember, always use raw. If you don't use raw, this is not going to work. Okay, so I'm going to run this cell. And it's going to be slow, maybe because I'm having this Teams running as well. So now I have this data frames stored in data. Now, what I'm going to do is I'm going to display this data. It's already displayed, but what happens is you just have to run the cell again. So here we have the data, which is from the PD pandas data frame, reading it. And then when I use the head method, so this method is part of this data frame, pandas data frame, I just look at the first few rows. Okay, so definitely data is much larger than this. If I click it now without the head, okay, I have like up to 891 rows. So there's 191. Let's go back to head again. Now, each row is a record of a person. Okay, so we've arbitrarily, or the data set has arbitrarily given each person a passenger ID. Then they label them as survived or not. So they gave them a label of 0 or 1. Then the class of the person, the name of the person, male, female, their age, how many siblings they had, did they have any parents or number of parents they had, the ticket ID, how much they paid for their ticket, what cabin they came from, and which class did they embark into. Okay. I can also go into different info of each feature. Okay, these are the features, right? So I can tell that, for example, passenger ID is an integer. It's a number. That's what it is, right? For example, the name, anything that is a string is considered an object. So here the name is an object. We have so a bunch of names, a bunch of strings, a bunch of floats as well. So for example, age was provided as a float, 22.0. So someone can have an age of 22.5, for example. Okay. And then finally, another method also that's nice to use in pandas data frame is the describe. And the describe is only used on numerical features. So you can see some features are not shown as such, like name is not here. So here I have some statistical insights. So we have the mean of the passenger ID, which is nonsensical, obviously, in this case. We have the standard deviation, for example, of the, let's see, we'll talk about age. Okay, so we have the mean age, now that's in the data set, the standard deviation, how spread the ages are, the minimum age, so we have some babies here, and then we have the percentiles, so the 25th percentile, where's the 50 percentile, the 75th percentile, and then the max age. Okay, so here's a bit of explanation. I already explained it, so I'm not going to go through it. Anybody who has the Google Colab can go through all of these explanations and can look at them in detail. Okay, I'll go on to the data cleaning part now. So in the data, as I said, it's subjective, right? So, but there are some things that are standard. Okay, so, for example, handling missing data. So the Titanic dataset often has missing data, and they did this on purpose. So what we need to do here is we want to figure out what we can do with this missing data. So for example, for what are we going to do with age? What are we going to do with the fare that's missing? What are we doing with the embarked that is missing, for example, if the cabin doesn't have anything? So the first thing is I want to know where the missing data is. So first thing is I do the, now my data frame is always called data. Okay, it's always, I named it as data. In some places you'll find another standard. They use DF, data frame. Here I just use data. Okay, I use the method called isNull. So it provides me a list of all the null values, features. And then here I take the sum of them. So this is a count. This is like an and then this is the count of all of those. So here what I end up with is I can see that passenger ID, there is nothing missing, survived, nothing missing, etc. But for the age, I have 177 records that are missing. And even more so with the cabin. I have so many with the cabin. Embarked, not so much. So 2 passengers, we don't know where they came from, S or C or whatnot. Okay. So one way of so first thing I want to show this missing data. So for example, for the age, I have here passenger ID number 6. His age is NaN, so it's not available. Okay. Next, what I want to do is I want to fill in the age. So one way of dealing with it is using just the average, the mean of the ages. So here I run it, and I get what I did was I run this method with filling of the none available of the age, okay, of the age here, and then I fill it in with the median of the age, okay, and I immediately replace it. Just replace this with that. And now if we look at this, let me run it again just in case. By the way, anytime you run a cell, you'll get a check mark next to it. So that's a nice thing to, and then also you'll get a numbers. Let me show you what I guess here the numbers are not shown, maybe because of my zoom. Let me just zoom out a little bit. Okay. Checking missing values. Not interesting. They used to put the numbers. I guess they did an update. Oh no, here it is. Okay, 8. This is the 8th cell that I ran. So yeah, so missing data here. We fill it in with all the ages. Now I'm going to be displaying those previously missing records with the age, and as you can see, that they all got replaced with the median age of 28. So on that, okay. Then I think I made yeah, because missing age was I ran this twice. So the second time there was no missing ages, so it didn't do anything. In either case, I'm going to be looking at the embarked as well. So here for the embarked, I have 2 passengers that we don't know where they entered. Now I'm going to be replacing those embarked with the one that is most used. Okay, so we're going to be using the mode. Okay, so we have the median, now we have the mode. And here I see that I've replaced it with S, class S. Okay. Now, for those that did not, that we don't know what cabin they came from, one way of dealing with them is, for example, dropping the whole cabin thing. So we don't need the cabin. And probably the cabin is redundant. Embarked and cabin might be this, it's almost the same. So the particular ID of the cabin is not that important in this case scenario. Again, this is subjective. So this is just my opinion. So I'll run that. And note, also I want to share a thing with you is that for every cell where if you run it, it modifies the data, I added a key here that says that this is a modifier. Okay, so your data will change. Okay, just a heads up. And then I'm going to be displaying the head again. So this is after cleaning. I have the ages, I have the embarked, etc. Okay, so when handling missing data, the key is to understand why the data is missing and how it impacts the analysis. There are different strategies. One of them is imputing, so replacing missing values with statistical estimates. And this is what we did here. We used the mean and the mode in different cases. Another thing is we can drop columns or drop data that we don't need. So it's best to drop columns with too many missing values. So for example, cabin is a column that is unneeded because there's so many data that is missing. And as I said, it might be even redundant when it comes to the embarked. All right. Now, also part of the cleaning, okay, is maybe converting some of the data. Now, the feature engineering, we're going to be doing the same thing, but there's a difference between feature engineering and cleaning the data. So with cleaning the data, maybe there's just a change of type. For example, here I'm converting some categorical data into numeric data. So one of which is the sex. Now, what I'm trying to do here is also I want to eliminate any type of textual data. So sex is now textual, name is another one, etc. So these are insignificant when and the model cannot deal with those, right? The model deals with mostly numerical or even numerical and or categorical, and I'll explain how we deal with categorical when we come to it. So converting categorical variables like sex and embarked into numerical form. So what we can do here is, again, this is a modifier. I'm converting sex. Anything that shows as female is going to be a 0, and anything that is shown as a male will be just 1. Okay, so I'll run that. Okay, and then I'll show you the changes. So now everything that is male, female, etc., has been changed to 1, 0, 0, 0, 1, and so on and so forth. Okay, and just to make sure that I only have zeros and ones, and make sure that I don't have like a male with a capital M and a female with a capital F or something like that, or female misspelled. What I did was I just checked what values are available in that column. And thankfully, I only have zeros and ones. So everything was changed to 0 and 1. There's nothing else. Now, with the embarked, there are 3 classes. There's the C class, the Q class, and the S class. Okay, and the issue with this data with embarked is what is the significance of C? What is the significance of Q? What is the significance of S? Maybe they don't have any ordinal significance. Okay, so one way of dealing with this kind of categorical data is using something called one-hot encoding. So if you have, for example, let's say, again, here we have 3 classes, what we can do is we can create 3 new features and replace the old feature that was textual or categorical, and give a 0 or a 1 if it's that class. So for example, passenger 1 is a class S. So now the feature of embarked S is going to be set to 1, while the rest are going to be set to 0. Okay, so with one-hot encoding, we create new columns, and this indicates whether there's that feature is present or not. And this is usually used with categories, as I said, and not with ordinal relationships. Okay, the embarked column is a good candidate for one-hot encoding. Now, label encoding, on the other hand, converts each category into a number. This is what we did with this with the sex feature. This method is suitable for ordinal data where the categories have a natural order. Now, I don't believe that this one should be ordinal, but I left it so that we have 2 types of conversions. So you'll see both of them there. So sex can also be one-hot encoded. So male either 0 or 1, female 0 and 1. Of course, you cannot have both of them at the same time. Okay. All right. And now we want to handle outliers. Okay. So problem with outliers is they can skew the analysis and the model training. Okay. And they can be like very strong. There's the skewness of them can be very strong. So there's different ways of figuring out what are the outliers here. So one of them is we can remove them completely, or we can cap them. Okay. So something that is really huge, we reduce its value. Something that is very small, we can increase its value. So we cap it. So one of them is using the quantile, the first quantile, the third quantile, get those, and then get the IQR. Okay. This is not a modifier, but I need to run it so that I have these values. Now, for visualization purposes, I'm going to show you the box plot and how the data is spread and where these quantiles are. So I'm going to be using Seaborn and Matplotlib. Okay, so here we're creating them, and here we can see that most of the data is lying down here. This is the 75% quantile, and this is, unfortunately, here I cannot tell how many there are here, but definitely from the ICQ we can. It's implicit in how the data is distributed. So even though this looks like a lot, it's not that many. Okay, these outliers are not that many. All right, so here I'm going to create a histogram. So this showcases the spread even better. Not better, but I mean, in terms of the quantity of each. So for example, most of the data is here in terms of the fair price. And then a lot of them here are just, these are outliers. So this one, for example, 500. Probably like a whole wing for themselves, or maybe it's just wrong. The data is wrong. Okay, so now we have the outlier condition. And then we look at these records. So we have 891, and then the number of outliers is 116. And then here, what this produces is let's say an array or a series of those records that are outliers and those that are not. Okay, so we have here that this is not an outlier, while number 1 is. Okay, and since number one is, I'm gonna show you what it looks like here in terms of the fair. Where is it? Fair. Yeah, 71. So it's a little bit, not too much, but a little bit enough of an outlier. So we have two options here, both of which are modifiers. So I have to choose carefully. One of them is we can remove the outliers completely. So this reduces our data set size, and the other is capping it. So I mean, I'll just go with the capping. Okay. So here's more explanation of what I mentioned earlier, and you can look at that. So, okay, next is the data exploration and analysis. So this is a critical step because now we want to understand our data after cleaning it. Okay, so we want to identify patterns, we want to see anomalies, and figure out some hypotheses. So the good thing here is I added the manual EDA, so we see how we're doing it manually, and then I also incorporated these libraries, Caleb and Data Prep. Okay. Now I'm not going to go into too much detail with the data exploration and analysis. There's a lot of data science and statistics involved, but just to showcase some of the tools that we used. So, for example, analyzing the survival rate, here we use Seaborn to plot the different classes. So, for example, those in class 1, those in class 2, and goes class 3, and what is the rate of survival? So majority here, we see that class 1 survived, less so in class 3. Okay. And then by gender, here we see that mostly women survived, less so for the men. Okay, and then here's some insights into this data. Looking at the age distribution, here we're using a histoplot, a histogram. So again, the distribution of the ages and yeah. And then what else is there? Here we have, okay, so now I want to go into some of the libraries that are used. So we have Caleb and Data Prep, and these can accelerate the EDA process. So they do a lot of automation. They generate a lot of these plots for you, rather than you deciding what plots to generate and visualize. So I said batteries included. Unfortunately, Caleb and Data Prep are batteries that are not included. So we have to install them. One way of doing this is using the pip install. Let me increase my size. I can't increase it. Okay, never mind. So here we install Caleb and we install Data Prep, and I need to run this again because the Google Colabs, they time out. So when they time out, then a lot of this data gets lost, including the installation. So bear with me here. Shouldn't take that long. Anyone has any questions while I'm installing?
Just
everything clear from my end.
I followed the link in Confluence page. It's reach out to another. Well, I couldn't find the one that you are presenting.
Oh, you're not? Okay. If it's at the very top, Siamak, this one.
Yeah, I
got
opened that.
the same one. At least it looks like the same one. Oh no, wait, yeah.
Is it different?
It is
it's
different. Yeah.
web scraping from BBC News and other stuff.
Okay.
I sent meta-analysis.
Could you refresh that one? I'm pretty sure we updated it. Warith, can you double check, see if this one got updated? I'm pretty sure we updated.
Wait, I just if you scroll, it's there. They're both there. If that makes sense. If you scroll further down, yeah, see, it starts off with the BBC stuff, but if you scroll down, it goes over the stuff you go over.
Oh, okay,
I believe.
Okay. No, it's different.
No, wait,
okay,
this is different.
You're absolutely right. It's incorrect. Warith, can you please take care of this one? Thank you. Okay.
Well, Warith
is Warith with us or no?
No, he's not here.
Okay, I'll update it. No worries. I'll do it offline.
By the way, the other one is also very interesting. It's good if we could have both of them.
I'll leave that one. That one is more showcasing other stuff, but independently. This one is a straight flow, so it shows everything. In the meantime, I will share it here so that everyone has it. Okay. And I apologize for that. Didn't get updated. Okay. Yeah. Let me just do a double share again. Copy link. Okay. Okay. Sorry about that. If the top one doesn't work, let's try this one because I used the explicit share button. Okay, so Caleb, for example, the nice thing about Caleb is it does a correlation matrix. So here, if I just call the correlation matrix method, it immediately shows me the correlation. Now, obviously, passenger ID with passenger ID has the highest correlation. Same thing with survive with survive. So a high correlation or a positive high correlation would be set to 1. Something that has a negative correlation would have a negative value. The higher the magnitude, the more correlation there is between these. So you have this whole matrix of what correlates with what. Okay. And then I want to show you the one that is done by data prep. Okay, so let me open that one. And here, this is like really automated. You just create a report. You just load this create report from data prep, which uses the EDA sub module. You run it, and so very nice visualization of even the correlation here. You have it. You can even, it's interactive, so you can choose like what is into how something interacts with something. Okay, so this is all available here. Probably it has more stuff than you really need, but it's available. So you can look at all of this and just use as you see fit. Okay. So this is the automated part of the EDA. Okay. So the key to EDA is to extract meaningful insights, to inform subsequent steps of the data science process, such as feature engineering, which I'm going to go into next, and the model selection. Okay. So EDA reveals important factors like the class of the like we saw just now, right? The class was important in deciding whether someone survives or not. There's some correlation there, gender, age, etc. Okay, so now we go into the feature engineering part of things. So here we can create new features, or we can even transform some features. Okay, so this one requires also another part, more creativity and analytical thinking. Okay, one thing is I'll go into the transformation that I didn't do here, but I will talk about its significance when I get to it. So first we'll go again. We have two different types of feature engineering. We have the manual part, and then I'm also going to show you the automated part. Okay, so we have feature-wise, which is really nice for automatic feature creation. So first one is we can create the family size. So this is one aspect we'd like to do. So now we created a new feature. So this is a new feature that is added, and this feature is made up of two things. It's made up of the number of siblings that you have. It's made up how many parents you have. So 0 if you don't have any parents with you in the ship on the ship, or so this is siblings and parents is all related to those that are with you on the Titanic, not outside. Obviously, everyone has a parent, but this is the number of parents that you have in the ship, and then +1, which is yourself. So this constitutes the family size. So after running this, you see that we have a new where is it? I think I have to scroll. There it is. Sorry. Family size. Everything new gets added towards the end, gets amended. So here we have the size, family size of 2, family size of 2, family size of 1, their loners, etc. And then here we can do some more analysis of how the family size is related to your to the survival rate. So this is large family, this is small family. Okay. So another thing we can do is that we can extract the title from the name. So Mr., Mrs., Doctor, etc. So this is a new feature we can also, this is now extracting a feature. So I'm going to run this. And here we have a few Misters, a few Mrs., Miss, Master, Reverend, Doctor, etc. And then the others are very small and insignificant. And then here we show who survived and who did it. So men are Mr., majority of them didn't survive, or the rate, let's say, the rate of or no, not the rate, sorry, the count. Here we show the count. So 400 of which have survived, less so with, or the majority didn't survive, and a few did survive, and so on and so forth. Now, jumping into the automatic part of things, I'm going to be using scikit-learn. First thing, of course, is we're going to do installation. Since feature-wise is not there, scikit-learn is there. I added it here. I don't know why I just did, but you don't have to do a scikit-learn installation. But in either case, it's there. So here we're doing installation. Okay. And once that's done and successfully built, great. Now, here we're using creating features, so polynomial features from different from different features, from other features. So here we can use a polynomial degree 2, where we use siblings and parents, and then we can create an array of interaction terms, and then from those we can create a feature as well. So I'm not going to be really using this feature. I just wanted to showcase it. So I'm going to run it, but I'm not going to incorporate it into our data. So just to a heads up on that. Okay. I'm going to skip this. Okay, and I'm going to skip this as well. I'm not going to add it. Next is using the feature-wise. This is for automated feature selection. Okay, and this is really nice one. So again, we import the feature-wise. We select what our target is. So in this case, we want to know if survived or not survived. So this is the Y of the features, or not the feature, it's the Y, it's the target. And then from that, we just call feature-wise with our data. We select what our target is going to be. So we're targeting survived. And we choose a correlation limit of 0.7. And verbose 2, it just means print stuff out. So I'm going to click on that. And it has really nice visualization as well. So, okay. So using, I think uses XGBoost to extract and figure out all the features that are relevant. So here we have visualization of the features and how they relate with each other, and what has been selected and what has been removed. So parent, if your parent is there or not, it seems to be insignificant, so it got removed. Fair, what fair you are, it got selected. Family size selected, but the sibling what was removed, and so on and so forth. Because here we have some redundancy, right? I mean, if I have family size, why would I need how many parents I had and why I have how many siblings? So probably here family size was enough in this case. So according to feature-wise package. And yeah, so here everything gets stored in the train data frame, and now only those features that got selected are part of this data frame. So this is like a subframe. Okay, so feature engineer has model performance. It introduces meaningful and relevant features, etc. Now, feature-wise, go ahead. Sorry.
So thank you. Sorry to interrupt. What does the feature-wise? It does is PCA or anything else?
No. It doesn't. It uses XGBoost. It doesn't use PCA in this case. Yeah, from what I gathered, I didn't go too deep into it, but this is what it's doing.
Okay.
Yeah. It's not using PCA. But yeah, PCA is another way, obviously. Yeah. And then now final section, or not the final. There's two more. but I usually always skip the visualization. I'm not very good with visualization. I prefer the modeling part. Actually, everyone prefers the modeling part, but this is like should be like the least amount of effort. Usually the cleaning is the most amount of effort. So model creation and evaluation is important in the data science lifecycle. Here we're going to be developing a classification model on the prepared data. Okay, so we'll look at the model training in terms of the manual way of doing it. Okay, first, of course, we're going to be importing the libraries. So here we're going to be using scikit-learn. Okay, excellent library for all the shallow learning models out there. And then we're going to prepare the data. So what do we mean by preparing the data? First, you have a data frame. So the data frame, first, you want to extract the features. And according to standards, we always call it an X and a capital X because it's a matrix, right? And then we have the target. So this is what we want to fit our model to. And that is called a Y, small y. Okay. Next, we split the data, and the nice thing is that scikit-learn has a nice function that does this. It's called train and split. We just feed it to the X, the Y, how we want to split our data. So we decided that the test size should be 0.3, and the random state is 42. You don't need to add this, but this means that it's good for reproducibility. So this is the same. This is a seed right now. So this is what's added. So I'm going to run this now. Should be very quick. Okay. And next is choosing the model. So the simplest model we're going to be choosing is logistic regression. As the name does not suggest, this is a classification model, but it uses regression methods. So there is a line that is being fit, etc., or not a straight line, but a logistic line, let's say. And so first we load this model, this foundational model, let's say, okay, that is not trained. So the parameters in this model are not fit for the data, and then we fit it. Okay, so we fit the X training with the Y training, skipping the testing. Okay, so the testing is hidden from us, and then we do the prediction. So Y predict is just to showcase. I think did I forget to run the model somewhere? Something error. Could not convert string to float. Okay, I think there's maybe an error. I ran this before something. Okay, we'll check. But in either case, the model will be created with the logistic regression. Then it will be fit, and then we can run it. I think maybe one of the data I skipped, and it remained as an object, so it's not numerical. So, but I'm not going to go back to it. I'm just going to leave it as is. I just want to continue explaining all the cells, so that it will help you in your project. Okay. Next is the evaluation of the model. So with classification problems, we use accuracy, and when we do the accuracy, we test the Y test with the Y prediction. So the prediction is the output of the model, while the Y test is the true values of the data. Okay. We can create a confusion matrix. So a 2x2 confusion matrix, and then we can also create a classification report. Okay. Another way of evaluating is we can use also cross-validation. So cross-validation is semi-automated, let's say. So you give it just the model, you give it the whole data, and you give it the whole target. Okay, and then you decide on how many folds you need. Okay, so for example, here we wanted to do 5 folds. What that means is that I take my whole data and then I split it into 5 parts. 1 part is for testing, and then 4 parts is for training. And then I change which fold is going to be a testing fold and which one is going to be a training fold. And I do that. And this is good because maybe the choice of the testing and the training made me lucky or made me unlucky. So I need to know the resilience of this model and how independent it is in terms of the choices of the testing and the training. Of course, everything is randomized in this case. Okay, and then for automated model training, so the good thing is that I think this is independent of each other. We're going to be using auto sklearn, lazy predict, and auto keras. Okay, I think we're almost done. So bear with me. I'll take a few minutes of your time, if you guys don't mind. Okay. So we'll be installing 3 packages. And then we're going to be doing as before, we're going to split the data into X and Y, X being the features, Y being the target, and then split it into testing and training. Okay. And then after that, after this installs, I'll go into the next one. We're going to be using a classification search, let's say. So here we're going to be searching all auto classifiers, okay, and then seeing which one, and then fitting them into the data here. Again, we evaluate the model using the accuracy by first getting the prediction of the X test into a Y prediction. And then we can also check the cross validation here. Okay, and then also lazy predict is another one. Lazy predict is an interesting one. I want to show you before we end. Okay, still running, still installing. Okay, so with lazy predict, you decide whether you want to use a classifier or regressor, etc. So here, of course, since it is a classification problem, it's really just 2 lines, right? It's amazing. Just you take in, you just create a lazy classifier object, okay, and then you do the you run it here, and then you get a whole report of all the models that it tested this data on. And it gives you all the accuracies for each one of them and all the stats of each and every one of them. And then from there, so one way of doing this is you start off with the automated part, and then you can do the manual part by tweaking from those selections of the automated models that got generated or that got decided. And then finally, we have also autokeras. Again, also note this. Everyone is following the same convention. Okay, so they all use the same methods, the same way the signature of that method, where you have like the input would be the first one positional input would be the training features, the second one would be the target, etc. So they all have the same one. So it's easy to go from autokeras to lazy predict to auto sklearn to scikit-learn, because they all have the same API convention. Okay, I think I'm going to stop here. Definitely look at the rest of this Google Colabs. I'm going to go back here, and I'll just explain the next part, which is the let's say the project that if you would like to join in and do them. We also have a Slack channel. I will share in the general channel that is part specific to our workshop. So not only will you be using it for this workshop, but it's going to be a continuation. So if we have any new notebooks we'd like to share with you guys, we'll share it there. If you have any questions about any notebook, something, you can also come to that channel and ask your questions. And also for the future data science workshop. So we're going to have one about project management, one that is targeted to software engineers, and another targeted to design. And we're going to hopefully have it all there, and hopefully we'll have a lot of engagement there. So let me go back to this one. Here it is. So we have the take-home study link. If you click on this one, and it's a very similar not similar data set, but let's say it's a similar problem. And here it's also split up into the same way. We have data collection, data cleaning, data exploration, feature engineering, etc. They're all there. Okay, and this is using the PIMA Indians diabetes data set. So if you go into the business understanding, we talk about the objectives, the value propositions, the problem statements, and then we have a bunch of notes to the students, so whoever is doing this. So if I go, for example, into the data cleaning part, I'm going to leave out some of the code, for example. Let's say, I guess maybe data cleaning. Okay, for example, here, correcting the data. Here I put a note for the students. Anywhere where there's a student Word here in the comments. I'll leave out some of the code. Now, this is not, there isn't a lot of overhead. You can easily figure this out. You can go into the old, to the Titanic data set, and you can figure out what the missing part is. So here you'll have some sort of hands-on experience with the actual data science lifecycle. And that's it. I don't know if we have enough time for questions, but I won't mind them.